All right, welcome back. On the last problem we did, we learned that not every set of equations will both be in slope-intercept form. You know that. We've worked on a variety of forms this year: standard form, point-slope form, slope-intercept form. So not everything always already has y or x isolated, but this one does. So let's look at our first set here. We have two equations. Only one of them has a variable isolated. That variable is right here. The y is all alone on its own side. And so I know that y is equal to negative 4x minus 10. So now I'm going to go to my other equation. And remember, this y is the exact same as this y. So what I'm doing is I'm keeping everything else the same, and I'm replacing the y with what y is equal to. Y is equal to negative 4x plus 10. What that does for me is it creates an equation that just has one type of variable instead of two. Now I have only x's instead of an x and a y. So now I'm going to distribute. The negative 3x just comes down, and I'm going to distribute. Don't forget that's a negative 4. It's a minus in front of your 4. A negative 4 times a negative 4 is a positive 16x. A negative 4 times a positive 10 is a negative 40, and we bring down the negative 1. These are like terms on the same side, so I combine them. Negative 3x plus 6x is 13x, minus 40 equals negative 1. I add 40 to each side to get the constants on the same side, so we get 13x equals 39. Divide both sides by 13, and so x equals 3. That means we're only half done. I've got the x part of my solution. Now I need the y part. I go back to the original equation that I started with. I can see that y is equal to negative 4 times whatever x is plus 10. Well, x is 3. So negative 4 times 3 is negative 12. Negative 12 plus 10 is negative 2. So my solution is 3 comma negative 2. Remember, it always should look like a coordinate point. Using the above problem as an example, you go back and try the second problem now. Go ahead and pause the video and try the second problem now. Welcome back. You should have seen that y was already isolated, and y is equal to negative 6x minus 5. So in the other equation, I'm going to replace y with negative 6x minus 5. So it becomes 2x minus 3 times something equals 55, because I'm replacing y with something else. I'm replacing y with this expression, so it's negative 6x minus 5, and we distribute. So we get 2x, we bring that down. This tells me to distribute. Negative 3 times negative 6 is positive 18 with the x. Negative 3 times negative 5 is positive 15, and that equals 55. We combine our like terms. They're on the same side. 2x and 18x make 20x, plus 15 equals 55. I'm going to rewrite this here so that I have some more room to write. This is now a two-step equation. I want to get my constants on the same side, so I subtract 15 from each side. 55 minus 15 becomes 40. Divide both sides by 20, and so x becomes 2. So that was the first part of your answer. Now we need to get the y value. Well, remember, y is equal to negative 6x minus 5. X is 2. So we replace that and then use our order of operations. Negative 6 times 2 is negative 12. Negative 12 minus 5 is negative 17. So that's 2 comma negative 17. Nice job. Let's take a pause here and talk about our code word for the day. Tuesday, April 28th, was my dog Layla's 14th birthday. This picture was taken when she was about 6 weeks old, right after we got her. Yesterday, she celebrated by sleeping most of the day and eating her breakfast like a little piglet. She's pretty old, so she spends most of her time sleeping, but still has fun running around the house and playing in the backyard. So happy birthday to Layla. Your code word for today is going to be Layla. So write that down, L-E-I-L-A. If you spell it wrong, that's okay. I'll get it right when I go back in and grade it. So your code word today is Layla. All right. Not every set of equations will both be in slope-intercept form. So remember, what we said was we're looking for a variable that's already isolated. So what I see is that x is already isolated, and x is equal to the expression negative 3y. What that means is I'm replacing x in the other equation. So this becomes 5 times negative 3y minus 2y equals 17. I don't need to really distribute because there's no plus or minus inside the parentheses. I'm just multiplying. 5 times negative 3 is negative 15 with the y. And then you want to be careful and check these with your calculator. Negative 15 minus 2 is not negative 13, it's negative 17. Why? This answer is going to get really ugly if you get that wrong. Divide both sides by negative 17. The negative 17s cancel, and anything divided by itself is 1. A positive divided by a negative is always a negative. So that's half of our answer. We know that y is negative 1. We know that x is negative 3 times whatever y is. Well, y is negative 1. Negative 3 times negative 1 is positive 3, and so x is 3 there. All right, pause the video, use the above problem as an example, and see if you can try this one on your own. You should have noticed that x was already isolated, and so x is equal to negative 2y plus 11. We're going to replace x in the other equation, so this becomes negative 2 times whatever x is, plus 3y equals 6. Everything in the equation stays the same. X is negative 2y plus 11, and so I need to distribute, because there is a plus or a minus on the inside. Negative 2 times negative 2 is positive 4y. Negative 2 times 11 is negative 22. And we bring down the plus 3y and bring down the 6. You should have noticed that you had some like terms here. The 4y and the 3y can combine to make 7y. We bring down the minus 22, bring down the 6. We're going to add 22 to each side to get the constants on the same side. So 7y equals 6 plus 22, which is 28. We want to isolate y by dividing both sides by 7. So y is 4. So remember, you've got half of your answer here. Y is 4. Now we need to go back. X is equal to negative 2 times whatever y is plus 11. Well, in this case, y is 4. So negative 2 times 4 plus 11, that's negative 8 plus 11, which is 3. And so you know the x value is 3. Nice job. All right, time to go back and do your IP. Go back to the Haiku page, click on the link to complete and submit your IP. Don't forget to work out your problems on a separate sheet of paper first. That way, if something happens to your submission, you can always go back and find this pretty easily. Also, don't forget that you should be logged into your school email first, otherwise the form won't let you log in. Good luck, and reach out to me if you have any questions. Bye.